Which of the following graphs represents the relationship between the force between 2 point charges and the distance between them? Option A. Graph between force and distance is a straight line, upward sloping. Option B. Graph between force and distance is a straight line, downward sloping. Option C. Graph between force and distance is a curve, upward sloping. Option D. Graph between force and distance is a curve, downward sloping. Correct answer, option D. Graph between force and distance is a downward sloping curve. A soap bubble is given a negative charge. Then its radius, option A, decreases. Option B, increases. Option C, remains unchanged. Option D, will change, but information is insufficient to predict whether it will increase or decrease. Correct answer, option B, increases. Electric lines of force about a negative point charge are: option A, circular, anticlockwise. Option B, circular, clockwise. Option C, radial inwards. Option D, radial outwards. Correct answer, option C, radial inwards. The potential inside a hollow spherical conductor, option A, is constant. Option B, varies directly as the distance from the center. Option C, varies inversely as the distance from the center. Option D, varies inversely as the square of the distance from the center. Correct option, option A, is constant. The electric field intensity on the surface of a charged conductor is: option A, 0. Option B, directed normally to the surface. Option C, directed tangentially to the surface. Option D, directed along 45° to the surface. Correct answer, option B, directed normally to the surface. Two plates are 1 centimeter apart and the potential difference between them is 10 volt. The electric field between the plates is: option A, 10 Newton per Coulomb. Option B, 250 Newton per Coulomb. Option C, 500 Newton per Coulomb. Option D, 1000 Newton per Coulomb. Correct answer, option D, 1000 Newton per Coulomb. At a large distance r, the electric field due to a dipole varies as: option A, 1 upon r. Option B, 1 upon r square. Option C, 1 upon r cube. Option D, 1 upon r raised to the power 4. Correct answer, option C, 1 upon r cube. As the electric charge on the surface of a hollow metal sphere increases, the electric field intensity inside the sphere, option A, decreases. Option B, increases. Option C, remains the same. Option D, may increase or decrease depending on the radius of the sphere. Correct answer, option C, remains the same. The capacitance unit of convenient size is: option A, farad. Option B, microfarad. Option C, kilofarad. Option D, megafarad. Correct answer, option B, microfarad. A and B are two spherical conductors of the same extent and size. A is solid and B is hollow. Both are charged to the same potential. If the charges on A and B are QA and QB respectively, then option A, QA is less than QB. Option B, QA is greater than QB but not double. Option C, QA equal to QB. Option D, QA equal to 2QB. Correct answer, option C, QA equal to QB. Two capacitors of capacities C1 and C2 are connected in parallel. If a charge Q is given to the assembly, it gets charged. The ratio of the charge on capacitor C1 to the charge on capacitor C2 is given by option A, C1 upon C2, option B, C2 upon C1, option C, C1 square upon C2 square, option D, C2 square upon C1 square. Correct answer, option A, C1 upon C2. Capacitors connected in series have option A, the same difference of potential across each capacitor. Option B, the effective capacitance equal to the sum of the individual capacitances. Option C, numerically the same charge on each plate of all the capacitors. Option D, none of the above. Correct answer, option C, numerically the same charge on each plate of all the capacitors. A large isolated metal sphere of radius r carries a fixed charge A. A small charge is placed at a distance s from its surface. It experiences a force which is option A, proportional to r, option B, inversely proportional to s, option C, inversely proportional to s square, option D, inversely proportional to r plus s whole square. Correct answer, option D, inversely proportional to r plus s whole square. 2-point charges plus 2 Coulomb and plus 6 Coulomb repel each other with a force of 12 Newton. If a charge of minus 4 Coulomb is given to each of these charges, the force will be option A, 4 Newton repulsive, option B, 4 Newton attractive, option C, 8 Newton repulsive, option D, 8 Newton attractive. Correct answer, option B, 4 Newton attractive. A capacitor connected to a 10-volt battery collects a charge of 40 microcoulomb with air as dielectric and 100 microcoulomb with oil as dielectric. The dielectric constant of the oil is option A, 4, option B, 2.5, option C, 0.4, option D, 1. Correct answer, option B, 2.5. The ratio of the electric force between two electrons to the gravitational force between them is of the order of option A, 10 raised to the power 42, option B, 10 raised to the power 40, option C, 10 raised to the power 36, option D, 10 raised to the power 32. Correct answer, option A, 10 raised to the power 42. The ratio of the electric force between two protons to the gravitational force between them is of the order of option A, 10 raised to the power 40, option B, 10 raised to the power 38, option C, 10 raised to the power 36, option D, 10 raised to the power 34. Correct answer, option C, 10 raised to the power 36. 3-point charges, each plus Q, are placed at the corners of an equilateral triangle of side R. The electric field at the center will be, if K is 1 upon 4 pi epsilon naught, option A, 3KQ upon R square, option B, KQ upon R square, option C, 3KQ upon 2R square, option D, 0. Correct answer, option D, 0. A given charge situated at a certain distance from a short electric dipole in the end-on position experiences a force F. If the distance of the charge is doubled, the force acting on the charge will be option A, 2F, option B, F by 2, option C, F by 4, option D, F by 8. Correct answer, option B, F by 8. 2-point charges Q1 4 microcoulomb and Q2 9 microcoulomb are placed 20 centimeter apart. The electric field due to them will be 0 on the line joining them at a distance of option A, 8 centimeter from Q1, option B, 8 centimeter from Q2, option C, 80 by 13 centimeter from Q1, option D, 80 by 13 centimeter from Q2. Correct answer, option A, 8 centimeter from Q1. The magnitude of the electric field required to just balance in air a 2 into 10 raised to the power minus 4 kilogram liquid drop carrying a charge of 9.8 into 10 raised to the power minus 2 microcoulomb is option A 10 raised to the power 4 Newton per coulomb, option B 2 into 10 raised to the power 4 Newton per coulomb, option C 4 into 10 raised to the power 4 Newton per coulomb, option D 5 into 10 raised to the power 4 Newton per coulomb. Correct answer option B 2 into 10 raised to the power 4 Newton per coulomb. Three charges small q, capital Q and 4q are placed in a straight line of length L at points distance 0, L by 2 and L respectively from one end. In order to make the net force on small q 0, the charge capital Q must be equal to option A minus q, option B minus 2 small q, option C minus small q by 2, option D small q. Correct answer option A minus small q. 2-point charges Q1 plus 2 Coulomb and Q2 minus 1 Coulomb are separated by a distance D. The position on the line joining the two charges where a third charge Q plus 1 Coulomb will be in equilibrium is at a distance option A d by root 2 from Q1 between Q1 and Q2, option B d by root 2 from Q1 away from Q2, option C d by root 2 minus 1 from Q2 between Q1 and Q2, option D d by root 2 minus 1 from Q2 away from Q1. Correct answer option D d by root 2 minus 1 from Q2 away from Q1. A charge Q is placed at each of the two opposite corners of a square. A charge small q is placed at each of the other two corners. If the resultant force on capital Q is 0, then option A capital Q equal to root 2 small q, option B capital Q equal to minus root 2 small q, option C capital Q equal to 2 root 2 small q, option D capital Q equal to minus 2 root 2 small q. Correct answer option D capital Q equal to minus 2 root 2 small q. Two free charges Q and 4q are placed at a distance d apart. A third charge capital Q is placed between them at a distance x from charge small q such that the system is in equilibrium. Then option A capital Q equal to 4 small q by 9 where x is d by 3. Option B capital Q equal to 4 small q by 9 where x is d by 4. Option C capital Q equal to minus 4 small q by 9 where x is d by 3. Option D capital Q equal to minus 4 small q by 9 where x is d by 4. Correct answer option C capital Q equal to minus 4 small q by 9 x is equal to d by 3.